Hello, good evening, and welcome to my physics room. My name is Bob Sherman, and I'm your son or daughter's physics teacher. Believe it or not, this is my 21st year teaching physics at Lyons Township. I can't believe how many years have gone by, but it's been great. I love teaching physics. I'm actually a graduate of LT, a class of 1996, and as a junior, I sat in this exact same room with these same blue chairs. While this is a virtual version of the room, I wanted to make sure that the background matched the experience that I hope that in not too long, our students will be able to physically be in the room. Like I said, I graduated in 1996. I went off to U of I for 4 years, and then I came right back to here. And I've been teaching here ever since, and I've loved all of my times teaching here. While early on in my career, I got a master's degree in educational administration, but I could never really convince myself that I wanted to leave the classroom, even while getting some of the training about the big picture ideas of public education. More recently, I've been pursuing my PhD in curriculum and instruction. My emphasis on my dissertation is based on self-efficacy and how people's beliefs are affecting the decisions they make, whether or not to pursue future STEM coursework, and specifically how women are more influenced by self-efficacy in their course enrollment choices. And while the dissertation's been moving along, recently I've taken a pause on that because this is a very unique year, and I don't believe that the data I could gather from this year's student population would really be transferable to future years of instruction. As well as, this is the time where we've got to focus a little bit more on our family, and for us as educators to focus on how best we can deliver remote instruction. But I hope to get back to it in not too long in the future. Personally, I like to run. I'm an avid runner. So if you live in the LaGrange area, because I am now a resident of LaGrange as well, you might see me run around the streets in an orange headband. It's my trademark look for whenever I run. And every other year, you might notice one house that's very well decorated on the holidays. And so every other year, I do a big Christmas light display on Brainerd. And this should be one of the years. So I'm thinking this is going to be the time to get out the boxes of lights in November, because it takes, 3-4 weeks to set up everything. There's 100 independent channels of lighting extravaganza that goes into the display, but it's a lot of fun. And I think it's a lot of fun to talk with the students about what goes into designing the programs and executing the programs and some circuitry things, all of which I love teaching in the fields of engineering and physics. So one of the things I want to talk about today was why I just love teaching physics. And the reason I like teaching physics is that it's both logical in its approach to solving problems, and that's usually helps me when I explain to students, when would I have to know this? Maybe not physics specifically. Not everybody's going to go on to become an engineer or very specifically related to physics fields, but you have to be able to understand how to approach a problem that at first might seem very difficult, but then once you break that problem down and you look at the individual parts, you talk about what you know, what you don't know. We call that listing givens in a word problem. And then you got to figure out how to solve it. What approach are you going to use? Oftentimes in physics, students will ask, what's the right equation? And different teachers have different ways of referring to equations as models, relationships. I often like to call them tools. How do you pick out the right tool from the toolbox, and you gain these tools as you learn these relationships? And that's part of the process, is, again, with identifying what you know, what you don't know. Which tool, which relationship is really going to be a good match for that particular situation. Then you go through and you solve, and whether the answer is numeric or not, what I care more about is when the students think about the answer. Does this answer make sense? I don't know. A calculator says so. Why does your calculator, why is this number an appropriate number? And if it's not, where would we have maybe gone wrong along the way? So making sense of your answers, I think, is very important to teaching physics. The other thing that's really cool about teaching physics is I get to talk about how the world works. And I get to talk about big, large scale things, experiences students may have had and wondered about. And I get to start to talk about those things. You know, and it ranges from, why is the sky blue? How do rainbows form? Right down to the oddities of life that maybe you didn't think about before. When we start talking about the idea of inertia, an object at rest stays at rest. Law, Newton's first law. And there's demonstrations we can do where you pull the tablecloth out from underneath all the dishes, and that's a fun one to talk about and do. But also I talk to kids about ice cubes in a cup. And you've ever had this case where you're trying to get a nice big drink, but all the ice cubes, they form like this ice dam in the cup, and if you spin the cup thinking that's going to solve your problem, it doesn't. The ice cubes are still there. The reason? Same as before. Object at rest stays at rest. So it's just fun to kind of talk about those different sort of applications of Newton's laws and other laws we'll study throughout the year. But I get to talk about why things are the way they are and deal with that wonder. So I really enjoy that aspect of teaching physics. As far as grading goes, the class is primarily summative based, and that's true of where this district is really moving, where the achievement, the grade, is founded on what you demonstrate summatively at the end, rather than being impacted by practice. And I understand a lot of that philosophy, and a lot of that makes sense, that we would never want to and should never penalize students for practice. We call that formative learning. There's different ways different teachers will phrase these things, but it's the idea of practice and that it's okay to make a mistake. One of the real foundational concepts we have to talk about in all of education is helping kids learn that it's okay to make mistakes. And I tell them from the beginning of this class, I say, you learn nothing from being right. You learn everything from being wrong. So it's okay to be wrong, because that means you're learning something. I'm doing something as a job. So that's one of the things that I make sure that kids understand. And so that's where this formative learning comes in, is that this is practice. Now, one thing that I have to make sure to the students is that just because it's practice, just because it's not part of the official grade, doesn't mean it's not required. And that can be tough for a student to understand, that something can be required, but not count for a grade. So in a sense, all we're really trying to tell the students is practice is required. And of course, that should make sense. You practice, you get better, and then you demonstrate what you've learned, and that's where all the tests come in, the summative assessments. So the overall student grade is almost all just test-based, which have retakes. All of this stuff is covered on the syllabus, but there are retakes for the tests, and then there's a lab component, because again, this is a lab science class. And so part of that overall indicator of understanding and their practices, their abilities to do science, is lab-based. So that's an important part. Generally, my philosophy as a teacher is that, yeah, you want to have fun in class, but it's really not my job to be a student's friend. It is my job to push them and support them as they grow in their knowledge and their understanding of physics. And that can be hard at times, and that can create a little bit of tension between me and a student, but that is only because what I'm trying to do for them, to raise them up in their understanding and help them grow. And I think it's been a real blessing over the years to just watch students grow, expand their knowledge, and then as they leave LT and move on to other great things. And this guiding principle about pushing students is true for every level of physics I teach, whether it's physics prep, AP physics, physics C, all these levels of physics that we offer at LT, and all of these levels that I have taught at LT. The principle is still the same of what I try to do with my physics students. Now, in the remote environment, there have been some adjustments we have to make. And so we have increased our flexibility as a district, of course. But now we are able to kind of push a little bit more this fall than we were able to in the spring. And so I think that's been beneficial to students, beneficial to teachers. but we have to adapt. And so it's been great using Zoom. You've probably heard my voice in your house. If you've all been home during the day, you'll probably hear my voice. Last spring, as well as now, I've Zoomed every day. I think it's very important to have that personal, face-to-face contact with the students in what is commonly referred as the synchronous learning model. I will still try and keep in mind some flexibility, but try and push kids to do some activities at home in a physical way. Sure, there's lots of computer simulations we can do some of these lab and these activities, but whenever possible, we're going to try and create, as a team, activities that students can do with typical household items, and then engage with the topic that we're trying to get them to learn, whether it's constant velocity or balancing forces. So if you find a broom balancing on a chair somewhere, or they're asking for a can of soup to roll across their floor, they're trying to do some physics, and they're trying to do it hands-on instead of just watching a video of something. But I also understand, again, with this idea of flexibility when we're working at home, that it might be difficult. So we want to make sure it's very clear. We never expect a student to buy something to do a lab activity. We are flexible in what equipment they use and encourage students to reach out to us if they're really struggling on finding just the right item to make the lab work. Because in the end, if this one activity, they don't have the right equipment to make it work, but they understand what we're trying to do, well, then I can give the student some sample data and say, okay, this time it didn't work out for you, but here's the data. This is what you would have measured. This is what you would have gained from performing the activity. And then let's go through and let's get back into the logic. Let's get back into the analysis about all that real data, and then draw some conclusions and find those relationships. So that's kind of our philosophy of how we want to try and do labs in this remote environment. Availability, as I've said, you have students reach out to me if they're having trouble with the labs, but that's broader. That's broader to any difficulties on the topic, clarity of the assignments, clarity of due dates, all these things. Email is the best way to get a hold of me. The students have my email address. You should be able to find it on the website, but it's rsherman@lths.net. And in the remote environment, there are the hours that we are engaged, the 7:30 to 3:15 slotted time that students are probably in front of a screen. Teachers are working with kids. There's Vita Plena time before school, after school. So as always, students, and some have already, which is great, started to take advantage of that Vita Plena time so that maybe we can have a one-on-one Zoom session and just kind of keep things on that path forward. So obviously just reach out anytime if you have any concerns, any questions. Email me, students email me. Things come up. Again, while we talk about needing cameras, how critical it is for me to see a student's face, for students to see my face, for students to see each other's faces, to connect in this remote environment. Things will happen, things will come up. And students have been really good about emailing me, say, okay, today's a day where I'm using someone else's computer, my camera's not working. Today's not a good day for the camera to be on, but they're reaching out to me and letting me know. So while yes, as a district, we expect all students to have their cameras on during the session, it's just another one of those degrees of flexibility. So those are kind of my basics about myself, why I love teaching physics. There's a ton of information on Canvas for the students to engage with. We have our very well laid out, I believe, sequence of topics and events and assessments and activities. It's been interesting. It's going to continue to be interesting, but I look forward to the future. I look forward to continuing to get to know your son or daughter in the physics classroom, even in the remote environment. We're going to get to know each other, and we're still going to have fun doing physics. So thank you for listening and joining in on this virtual open house. So again, if you've got any questions, drop me an email, and so we can connect if need be. Take care. Have a good rest of your evening.